Welcome back. This is a continuation on circular motion. In this video, we will discuss about centripetal acceleration, centripetal force, and angular acceleration. So we will start with centripetal acceleration. It is defined as the rate of change of velocity due to change in direction of a body in circular motion. The rate of change of velocity due to change in the direction of a body in circular motion. So you know that for a body that is moving in circular motion, the direction is changing always in order to assume that circular orbit or that circular track. So one thing you have to know about the centripetal acceleration is that its direction is always towards the center of a circle. This is also true for centripetal force. Remember, the direction of centripetal acceleration and centripetal force will always be towards the center of a circle. Okay? The unit of centripetal acceleration is meter per second squared, which can be expressed as either this way or this way. So if we have a diagram and let's say we have an object that is situated in this position here, that is moving along the circumference of the circle, we have to know that the centripetal acceleration is always going to be directed towards the center of the circle. This is going to be the direction of the centripetal acceleration. It is towards the center of the circle. It is important to note that the linear velocity is always tangent to the circumference of the circle. Okay? So that is the direction of the linear velocity, v. So with this, we can comfortably say that the direction of the centripetal acceleration and the direction of the linear velocity are exactly at right angles or 90 degrees. It is also important to note that the direction of the centripetal force is also towards the center of the circle. Since force causes acceleration, they have to be in the same direction. Okay? So moving on. In this diagram, we have a body that is initially at this position. If this body is to move in circular motion, that is along the circumference of the circle, let's say it moves from here, coming way down to this position here, then it has made an angular displacement. So let's try to indicate the initial and the final position. This is the initial position of the body, and this is the final position of the body here. At any point, the body does have velocity. So let's try to indicate the velocity at the first point. Let's say this is point A and this is point B. So the velocities at these points can be indicated as VA at A and VB at position B. Now, if we should connect the positions of the body to the center of the circle, we're going to have it like this. So as you can see, we have an angular displacement here that is theta. This is the initial position of the body with a tangential velocity VA, and this is the final position of the body with a tangential velocity VB. I would like you to note that the magnitudes of the velocity at these two different positions are the same. Okay? The velocity for the body at position A is the same as the velocity of the body at position B. Okay? The only difference is that the body has different directions at different positions on the circumference of the circle. We know that from this position, along the circumference of the circle to this position, the distance or displacement in between the two positions is called delta S. This is the radius of the circle. So if we should draw a vector diagram for the displacement and the radius, we'll have something like this. This is theta, this is the radius, and this curve that we have here can be a straight line here if we are considering the fact that we are expressing the angle in radians, and the angular displacement, we've said that the length of the arc is equal to the radius of the circle, if you can remember that. So this line will be our delta S. That is going to be the same as this curve here. So that is our triangle for R and delta S. What we want to do now is to draw a vector diagram for the velocities of the body in these two different positions. In kinematics, what we are familiarized with is that a body accelerates if there is a change in the magnitude of the velocity. But remember, since velocity is a vector quantity, even if the direction changes without the change in the magnitude, then there is still going to be acceleration. So on the circular motion here, we are talking about having a body moving with a constant speed, okay, or velocity. But here, the velocity that we are considering is that it is changing its direction. So as you can see here, the velocity is heading towards this way, and at this position is heading towards this way. So it is still acceleration. What I want you to have at the back of your mind is that a body that changes its direction is also in acceleration, just like a body that increases its velocity or a body that decreases its velocity, which we call deceleration. Do not be confused with it. So for now, I want to draw a vector diagram for the velocities at the two positions. So the way we're going to draw that is that we're going to consider how we have the directions of the velocities. At this position, we have the velocity moving this way. So let's try to draw it that way. So that is VA, and at position B, we have it moving this way. So let's try to draw it like that. This will be the direction of VB. So what can we do next is that we have to connect these two lines, okay? That will be the resultant vector. And we can call that delta V or change in V. So it turns out that this will be the angle theta that will be similar to the angle that we have here. So these two triangles that we have here are similar triangles. That is what I want you to know. Because if you rotate one of them, it is going to be the same like the other one. For this triangle, we are talking about lengths, but for this triangle, we are talking about velocities, okay? But they are similar triangles. And if I should just take this diagram and rotate it, you will see what I'm talking about. Let me just try to get that here. If we get the triangle here and we rotate it, you can see it is going to be similar to this triangle here. That tells us that they are similar triangles. So we know that we can use the angular displacement to be able to determine the formula for the centripetal acceleration. We know that angular displacement theta could be equal to the change in the velocity divided by the instantaneous velocity. That is, if you are considering delta V divided by any of these. So whether you say divide by VA or VB is the same as V, because the velocity in terms of magnitude is the same, does not change. Okay? So this is going to be equal to change in the displacement divided by R. I hope you understand that. So that is to say, delta V all over V is equal to delta S all over R. So I can divide both sides by delta T in order to be able to get something. So let's say divide both sides by delta T. That is going to be delta V all over V times 1 over delta T. Okay, so that is how I am dividing by delta T. This is equal to delta S all over R times 1 over delta T. So if we do that, what are we going to have? We're going to have delta V all over V delta T is equal to delta S all over R delta T. So I can say 1 over V times delta V all over delta T. This is equal to 1 all over R times delta S all over delta T. I am just doing rearrangement. So in physics, what is delta V all over delta T? When you have velocity divided by time, that is change of velocity divided by change of time, that is acceleration. And again, if you have delta S divided by delta T, what is that? Change in the displacement divided by change in time, that is velocity. So which means in their place, we can substitute that. Then we will have, for this equation here, we're going to have 1 over V times acceleration is equal to 1 all over R times the velocity. So 1 times A is A divided by V. This is equal to 1 times V is V divided by R. So if you cross multiply, you will have AR is equal to V squared. So to find the acceleration, you divide both sides by R. So if you have AR is equal to V squared and you divide both sides by R, what are you going to have? A is equal to V squared divided by R. So that is how we are able to have the centripetal acceleration is equal to V squared divided by R. But we know that V is equal to omega R. So if we substitute that into this equation, we're going to have another equation for acceleration. That is, acceleration is equal to omega R all squared divided by R. So acceleration will be equal to omega square R square divided by R. So acceleration will be equal to omega square R, because R squared divided by R, one of the R will be cancelled. So that is how we have acceleration as omega square R. Again, from acceleration is equal to V squared divided by R, we have already derived in our previous video that V is equal to 2 pi R divided by the period. Is that not so? So if I should substitute that into this equation here, we'll have acceleration is equal to V is 2 pi R all over the period, all squared, divided by R. So acceleration will be equal to 2 square is 4, pi square, R square, divided by T square, divided by R. So we can say acceleration is equal to 4 pi square R square divided by T square. We can use the short division and R, that is the denominator. So acceleration will be 4 pi square R square divided by T square times 1 all over R. So what is going to happen here? This R goes into itself once. Into here is going to cancel one of the R's. What will we have then? We're going to have acceleration is equal to 4 pi square R divided by T squared. So this is also another formula for acceleration. So in summary, centripetal acceleration can be V squared divided by R. Centripetal acceleration can be omega square R, or centripetal acceleration can be 4 pi square R divided by T squared. So these are the formulae that you can have for centripetal acceleration. Okay? Moving on to centripetal force. It says it is the force that acts on a body moving in a circular motion and is directed towards the center around which the body is moving. The unit of centripetal force is newtons. So one thing you have to understand or include in the definition of the centripetal force is that it is the force that keeps the object in its orbit, and it is always directed towards the center of the circle. We have talked about that previously. So to remind ourselves again, if you have a circle, let's say the position of the body is here, and if this is the center of the circle, the centripetal force is always going to act towards the center of the circle. Okay? This is the centripetal force, F. It is different from centrifugal force, which acts in the opposite direction. That is, it moves away from the center of the circle. That is the difference, okay, between centripetal force and centrifugal force. For centripetal force, it is a force that acts towards the center of the circle, and because it is always acting towards the center of the circle, it is the one that is keeping the object in its circular track. All right? So I want to ask you a quick question. Why is it that a body that was previously moving in circular motion tied to a string will move in a straight line whenever the string that is attached to the body is suddenly cut? The reason for this is, as the body is moving in circular motion, the string that is attached to it is having tension, and that tension is the centripetal force. So because it was having centripetal force, because it was having a centripetal force, its motion will be circular, all right? But once the string is suddenly cut, the object loses its centripetal force, and therefore it has to go in the direction of the tangential velocity. And you know that the tangential velocity is always tangent to the circle, and it will move straight instead of moving in circle. So we're going to use Newton's second law of motion to derive the equations for centripetal force. So using F is equal to ma, the force will be equal to mass times acceleration. One of the formula that we have was v squared divided by r. So therefore F will be equal to mv squared all over r. Again, using F is equal to ma, we're going to have F is equal to m into what is the other formula for acceleration is omega square r. So we can have F is equal to m omega square r. Again, if we use F is equal to ma, so F is going to be equal to m. The third formula that we have for acceleration was 4 pi square r all over t square. So therefore F will be equal to 4m pi square r divided by t square. All right. In summary, we can have three formulae for the centripetal force. We can have F is equal to mv squared divided by r. We can have F is equal to m omega square r. We can have F is equal to 4m pi square r divided by t squared. Okay, so just know how to derive them. Moving on to angular acceleration. Angular acceleration is the change in the angular velocity per change in time needed to cause such a change. The change in the angular velocity per change in time, that is called angular acceleration. The unit of angular acceleration is radians per second or radians per second squared. Okay, you can express it either this way, or this way. Now, by definition, centripetal acceleration is represented with the symbol alpha. We said it is equal to change in the angular velocity divided by change in time. So if the object is changing its angular velocity, let's say we have a diagram like this, and This is the initial position of the body here, and this is the final position of the body. The body at here has an angular velocity omega 1 and an angular velocity here as omega 2. The time here, let's say, is t1. The time here, let's say, is t2. So it means, since we are talking about change in angular velocity divided by change in time, it means that the angular acceleration will be equal to omega 2 minus omega 1 divided by t2 minus t1. So that is all that I have for you under the terms associated with circular motion. In our next video, we will try to do conversion of units pertaining to circular motion. Then after that, we will begin to solve problems related to circular motion. Thank you very much for watching this video. If this is the first time of visiting this channel, like our video, share it, and please subscribe to the channel.